Alright, welcome to the Geometry Unit 9 practice test video. Thank you for investing the time and getting ready for this next test. It is our last unit test of the year. Alright, so first off we're going to go over the answers. In fact, if you have not worked out the practice test yet, it is way better to work out the problems to the best of your ability and then view this video. So if you haven't tried to work out all the problems, or as many as you can, pause the video, go work them out, and then come back, and that way you can check your answers. So laid out on the screen right now are the answers to the first 7 problems. If you need more time to check your work, go ahead and pause the video. Up next, we'll show the next couple of pages. Alright, here is the next couple pages of answers. Just like before, if you need more time to check and see how you did, just pause the video. You can have as much time as you need. Okay, up next, a couple more pages. Okay, here are the answers for numbers 16 through 18. Pause the video if you need more time to check your own answers. Okay, here's problem number 19, the last problem. Alright, up next we will go through each problem and work it out and explain what we are doing. Number 1 gives us a pair of cylinders, one that we would call a right cylinder because its height is perpendicular with its base, and then this other cylinder over here that that's height is not perpendicular with base. In other words, this is called an oblique cylinder. Okay, and they give us a couple of important facts up here. First of all, they tell us that line N and line M are parallel. Okay, so we can see it really doesn't matter where you check the height for these. We know we have to go straight down. You're going to get the same distance. So basically, since these are parallel, we know that the heights are the same. Okay, it's just that this one goes crooked, but when you measure height, you have to go straight down, and because they're parallel, we can see that the heights are the same. They also tell us that the radii of the two cylinders are congruent. Okay, so if we are talking about this distance, it's the same as this distance. Okay, so if the radii are the same, what about the area of these two circles? Well, if the radii are the same, wouldn't we get the same amount of area? And definitely you can see that this problem has to do with Cavalieri's principle. Cavalieri's principle, which basically says if you just kind of slant something, it really doesn't change the amount of volume you get. In other words, if they have the same height and the same bases, and you check all the cross sections and they're all the same shape, then you have the same volume, the same amount there. So let's go through these one at a time. This one says the cylinders have congruent bases. Well, would those circles be the same if they have the same radii? Definitely, that is true. So I'm going to circle that. The volume of cylinder A, the oblique one, is greater than the volume of cylinder B. Well, because of Cavalieri's principle, we know that they have the same volume, not greater volume, so that is false. I'm going to cross that out. The volume of cylinder A is less than the volume of cylinder B. Nope. Really, you have the same amount. They should be equal, so one isn't bigger or smaller than the other. The two cylinders have congruent heights. Well, yep, that's true. Remember, you have to measure height going straight down, and because those lines are parallel, that is true. Okay, the volume of cylinder A is equal to the volume of cylinder B. Yep, that's what Cavalieri says, that they are going to be equal if they have the same base and the same height, and they do. The cross sections are circles. So is that true? If we did a cross section of both of these, we would still get circles? That is true. Okay, so basically this question just tests you on Cavalieri's principle, and you'll go through the question and apply that principle to pick out which ones are right. Problem number 2 says if the diameter of a soccer ball, and maybe that's an important word right there, the diameter all the way across the ball is 8 inches. So what would it be if we are only going for the radius? After all, we can definitely see the soccer ball is a sphere, and the volume formula for a sphere is equal to what? 4 times pi times the radius cubed all over 3. Remember, if you're in a college prep class, that formula will be provided to you. If you're in a geometry honors class, you'll have to have this formula memorized. In any event, we can see that we need to have the radius. So be careful that you don't accidentally use the diameter. So what if the radius is 8 inches? How much would, if the diameter is 8 inches, how much is the radius? Well, that would give us a radius of 4 inches. We're going to take that 4 inches and very simply drop it in for the radius. So volume is equal to 4 times pi times my radius cubed all over 3, and we're going to fill in our 4 right there. Okay, 4 times 4 is 16. This is really 4 times 4 times 4, right? So we get 16 times 4, which comes out to be 64. If you multiply that by 4 more, 4 times 64 comes out to be 256. So we end up with volume is equal to 256 pi all over 3. And they want us to use 3.14 for pi. So you would just do 256 times pi times 3 on your calculator, or divided by 3 on your calculator, and you would round it off to the nearest whole number. So if you type this in on your calculator, 256 times 3.14, I'm doing it on my calculator right now, and then divide it by 3, you end up with 267.9. And what does the 9 do to the 7? It's either going to leave it or move it up, and in this case it would definitely move it up to 268 inches cubed would be the answer that we would look for. So you will get to use a calculator on this test. You just have to carefully type in the numbers and do the correct rounding. Number 3. A cylinder and a pyramid are shown, and they want us to figure out volumes and decide which one has the greater volume. So this is really a two-part problem. On one problem, I need to find the volume of the cylinder, and on the other part of the problem, I need to find the volume of, what is this shape? This is a pyramid. Okay, so let's jump up one at a time. So the volume formula for a cylinder is what? Area of the base times the height. So the area of the base, pi r squared, times height, so pi r squared times height. Okay, and let's fill in what would the radius be? Well, the radius on the cylinder is definitely 1, and the height is 6. Okay, 1 squared is still 1, and 1 times 6 is 6 pi. That's what we get for that one. Okay, it does want us to round to the nearest whole number, so if I do 6 times 3.14, 6 times 3.14 equals 18.84, and they want us to round to the nearest whole number. So I'm going to look at the 8. What does the 8 do to the 8? The other 8, it turns it into 9. So we're going to call this 9 inches cubed when we round it off. Alright, our next job is to work on the volume of the pyramid. So this is what? Area of the base times the height, but because it gets narrower at the top, we have to divide by 3. Okay, and what if I was looking at the base of this particular pyramid? It's a rectangle, right? So let's find the area of that base. It would be what? Length times width. So in this case, that's 4 times 2, or 8. So area of the base is 8. The height right there is 6. And don't forget to divide it all by 3. I notice I can divide early, so 3 goes into 6 twice, and 8 times 2 comes out to be exactly 16 inches cubed. So who had more volume? Well, definitely the cylinder had more volume. So the volume of the cylinder is greater than the volume of the pyramid. Okay, now be careful. Don't expect the problem to work out exactly the same on the test. Just do your work and see what you get. The pyramid on the test might have more, or they might even mix in some different shapes. You just have to realize you have to do 2 separate problems for whatever you get, and then compare your results. Number 4 tells us we're going to make a three-dimensional geometric object by rotating the flag 363 degrees around the flagpole. In other words, we're going to spin this just like that. So what shape would it make if it went around there? Well, I'll remind you that anytime you're rotating something, you always get something with a circle. So really you have to pick from what things have circles in them, what three-dimensional geometric objects. We got cylinders, we've got cones, and we've got spheres. That's basically what we have to pick from that are associated with circles. So what would you get if you spun this around? And really there's just one way to do this. You have to imagine what it would look like in your mind. Your teacher might have had you spin something on your pencil in class so that you could see it for yourself. So maybe you can summon those memories. Anyway, this one would come out to be a cylinder. Okay, and this one over here, if that spun around, that would give us a cone. So you just have to see it in your mind's eye. Number 5 shows us a cylinder. Actually, it says cone right there, but this is not a cone. This is a cylinder. And they want to know, we're going to do some cross sections. And in one case, we're going to do a cross section along the vertical axis. In other words, it's kind of like we're taking an aluminum can and we're getting out a knife and we're cutting from the top of the can straight down, opening it up and looking at what it would look like. So if we did do that and kind of chopped a can in half from the top down, that's a vertical cross section, what shape would you see? And remember, cross sections are always two-dimensional, so it's going to be some sort of flat plane figure. If you chop down, wouldn't you get a rectangle? Would be the outside edge of the can. Okay, and then what if we took a slice horizontally? So instead of slicing down through the can, what if you kind of laid it on its side and started cutting on the round part and opened up the can and looked at it? The horizontal cross section would be a circle. And once again, there's no real mathematical way to do this. You just have to have an imagination in your mind and be able to see what it would look like if you did one of these slices. And thinking of a slice is a great way to think of a cross section. Number 6, we have a triangle that's dilated by a scale factor of 3 to 5 to form a triangle DEF, which would be bigger, right? For every 3 units in triangle ABC, we're going to get 5 units in triangle DEF. And then they tell us that the smaller triangle ABC has an area of 36 inches, and they want us to find the area of triangle DEF. So we are definitely going to start this problem with a blank proportion. And in one of those proportions, we're simply going to write our scale factor, 3 to 5. Okay, over here, we're going to write a ratio of areas. So the area right here, 36 inches, belongs to triangle ABC, the smaller one. So should I put it on top with the 3 or on the bottom with the 5? Well, if it's a smaller triangle, it definitely would go up here on the top. And since I'm trying to find out the area of the larger one, I'm going to call this one X. Everything looks great except this scale factor or ratio of similarity is not equal to a ratio of areas. The only time it would be equal is if we came over here to our ratio of similarity, our scale factor, and we squared it. You'll remember this from the class that you had. Perimeters are equal. Areas are only equal when you square. And what about volumes? Volumes are only equal if you cube. Okay, so once we've made this adjustment, because we are working with area, by squaring the ratio, the scale factor, we can just do the algebra. So how about 3 squared? That would be 9. 5 squared would be 25, is equal to 36 over x. Now that we've done the squaring, we can do our cross multiplication. So we get what? 9x equals 25 times 36. 25 times 36. And let me get my calculator out. 25 times 36 equals, that comes out to, I'm going to work this out, it comes out to be 900. When I divide both sides by 9, I get x by itself, and 900 divided by 9 comes out to be 100, and we're dealing with what? Square inches. 100 inches squared for the area of the larger triangle. Okay, so start with a blank proportion, and most of all, don't forget, if you're working with area, you have to square. If you're working with volume, you have to cube. And if you're working with perimeter, you don't do anything. You just make the ratios equal to each other and solve. 100 inches squared. Alright, the scale factor of 2 similar geometric objects is 3 to 7, and they want us to figure out the scale factor or the ratio of their volumes. Okay, so basically we're going to take 3 over 7, and because it's volumes, would we leave it, square it, or cube it? Well, if it's volumes, what do? You cube it. Okay, and the last thing we have to do is just work out that would be. So what is 3 to the 3rd power? That's 3 times 3 times 3. That's 9 times 3. That comes out to be 27. And 7 times 7 times 7, that basically makes what? 49 times 7, which comes out to be 343. So we get a ratio of 27 over 343. Now if they change this to area or surface area on the test, we wouldn't cube, we would square. And if they ask for the scale factor of some perimeters, you would just leave it 3 to 7 because you don't have to change that. Alright, number 8 says the dimensions of the middle pyramid right here, the biggest one, is 3 times the dimension of the smaller pyramid. Okay? And by saying that, they're basically saying that the larger pyramid is similar to it, it's just 3 times bigger. In fact, what would the ratio be if it was 3 times bigger? For every 3 units in the big pyramid, that's going to give you what, 1 unit in the small pyramid? That's what 3 times the dimensions mean. Then they tell us the volume of the middle pyramid, which is the bigger one, is this, and they now want to know the volume of the smaller pyramid. So we're going to start with a blank proportion. We're going to put the scale factor of the two pyramids, 3 to 1. Okay, if they're giving us the volume of the larger pyramid, should I put it on top with the 3 or on the bottom with the 1? Well, of course, it would go on top with the larger one. So we're going to put 2,500,000 on top. The volume of the smaller one would go here, and the only problem is the scale factor and the volumes are not really equal unless you square or cube. Well, we are talking volume here, so what does that mean? Cube. Okay, so we got the geometry done. Let's just do a little algebra. What is 3 to the third power? Well, 3 times 3 times 3 is 9 times 3, or 27. 1 times 1 times 1, that's pretty easy. It's still 1, equals 2,500,000 all over x. That number might look kind of intimidating, but remember, you'll be using the calculator, so it'll do all the calculations for you. But remember, that does not replace you being able to do the algebra. Please resist the temptation to skip ahead and oh, I already know, I just want to get to my calculator. Your calculator should really only do the little computation at the end. You still need to do all the algebra. If you start skipping steps, the chance of you making kind of a mistake you didn't notice is really starts rising. Alright, let's cross multiply. 27 times x is 27x, and 1 times 2,500,000 is still just 2,500,000. We'll divide both sides by 27, and we'll end up with what x is equal to. And it does say we can round this off to the nearest whole number. So on my calculator, I'm going to type in 2,500,000, and I'm going to divide it by 27, and it comes out to equal 92,592 point. The next number is 5, and I'm going to round off. So who do I look at? I'm going to look at this one if they want the nearest whole number. Leave it a 2 or move it up to a 3. Well, that 5 will move it up, so we'll end up with 92,593, and our units are what? Cubic meters. Cubic meters, that would be the answer to this problem. Probably the most important part of this problem is to remember that if you're dealing with volumes, you have to cube to make it equal to the ratio of volumes. Number 9 gives us this three-dimensional castle and asks us to kind of pick out some objects, some three-dimensional objects that we've learned about this year or in this unit. And I think what I'm going to do is write down all the ones we've studied, and then we're just going to see if we can pick any of them out. So we learned about prisms. We learned about cylinders. Right? And prisms and cylinders are a lot like each other, except this cylinders use a circle. We also learned about pyramids. And we learned about cones. Those are also a lot alike, except cones have circles. And then finally we learned about spheres. So that's really all we have to look for. So let's see if we can find anything. Well, how about that guy right there, or even this guy right here? Aren't both of those prisms? So we definitely have some prisms. Okay, and let's see. How about this thing right here? Is that a pyramid or is that a cone? Well, we can see it's kind of rounded right there, so that is definitely a cone. Okay, anything else you see? Well, how about if that's a cone up there, what about that thing right there? Wouldn't that be a cylinder? Definitely a cylinder. Okay, now let's see if we can find any pyramids. Now be careful, these kind of look triangular, but you'll notice all of those are attached to round parts of the building. So none of them are pyramids, they're all cones, and so there's no pyramids. And do you see any spheres? Any spheres up there? Like a round ball? Nope, so those would be the ones that we see right there. Okay, so you'll look at the picture they give you on the test and kind of scope it out and figure out which ones are there and which ones aren't. Alright, so they're making an ice cream at Dairy Queen. They tell us right off the bat that we are working with a cone. They tell us the radius and the height, and then they want to know the amount of ice cream that will fill one cone. So what is the amount of ice cream? Isn't that a volume problem? So this is basically, very simply, the volume of a cone. Okay, so the volume of a cone, what formula is that? Pi r squared times the height, but because it gets narrower, it's not the whole volume like in a cylinder, so we end up dividing by 3. Okay, so let's very simply plug in what we need to know. We just need a radius, we need a height, and then we'll need to divide by 3. So how about the radius? Well, it's 3 centimeters. And how about the height? It's 15 centimeters. Okay, and you have to be careful. When things are being squared, you need to be very careful about canceling. So we wouldn't cancel those 3's, but can I cancel the 3 and the 15? Yep, I can definitely do that. That would go 5 times. So how about 3 squared? 3 squared would be 9. So 9 times 5 times pi all works out to be 45 pi. We're going to take our calculator and type in 3.14 times 45. They do want us to round off to the nearest tenth this time, so we're going to look at the second decimal place to round off the first one, and 45 times 3.14 all comes out to be 141.3, and it kind of goes evenly, so there's nothing here to round off, so we get a volume of 141.3, and our units are centimeters, and we just did volume, so there would be our answer. Okay, so remember, college prep students, you'll receive these formulas. You just need to make sure you pick the right one, fill it out correctly, and do the correct math. Honor students, of course, you'll have to have this formula memorized and then pick it and fill it out correctly.
All right, here's number 11. Very simply, they give us this three-dimensional solid. We have to identify it so that we can calculate its volume, and hopefully we can all see that this is a pyramid. So you will have a formula sheet on the test, and you just need to find the volume formula for a pyramid, which is volume is equal to area of the base times my regular height, all divided by 3. Okay, we might remember that prisms and pyramids have a lot in common, and but as a pyramid goes up, it gets narrower at the top, and we lose some volume, and that's why we have to divide by 3. Okay, so first things first, let's see if we can find our base. Well, our base is just right across from the top of our pyramid, so this down here, this would be our base. And in fact, the shape of our base, this way here, we kind of have to figure it out so we can calculate its area. In other words, you'll be given the volume formulas for the problems. What you won't be given are the area formulas you need to use. And hopefully we can all see that this is a rectangle, and that means the area formula for a rectangle should be length times width. And there's our length and there's our width. I bet we can do this in our head. The area for this rectangle that's 10 by 9 centimeters would have to come out to be 90 centimeters squared. Alright, so the area of my base is done. Let's see if we can kind of fill this out. Area of my base times my height, all divided by 3. And I just got done working out the area of my base, and it came out to be 90. So my height, what is my height? Well, my height is from the very top of the pyramid all the way straight down to the base. And I can see that it comes out to be 12 centimeters. So I'm going to plug that in. This comes out to be 12 centimeters, and the last thing I need to do is just work out all the math. I'm noticing that both 90 and 12 are divisible by 3. I could multiply first and then divide by 3, but I could also divide by 3 first. Just make sure you don't divide twice by 3. You can either take it out of the 90 or take it out of the 12 in this case, but don't take it out of both. 3 goes into 90 30 times. And if I do 30 times 12, I'll get a final volume of 360, and my units are centimeters, and this is volume, so it would be centimeters cubed.
Number 12 is a trigonometry problem, and I guess I would just warn you, some students have a hard time handling the fact that the answers are right down here. If I were you, I would ignore those and just do the trig, get it all the way to the answer, and then just match it. Don't let these distract you. So if this is my angle, I need to name these two sides. So how about the 18? Opposite, adjacent, or hypotenuse? Well, that is definitely an adjacent side. And how about the x? Opposite or hypotenuse? Well, we can see it is definitely the hypotenuse. If I use SOHCAHTOA, I should be able to pick the right ratio. So who uses adjacent and hypotenuse? That is a cosine problem. So the cosine of a 32-degree angle is equal to, put my ratio down, alright. So who goes on top? Adjacent goes on top, so the adjacent side is 18 and the hypotenuse is x. Alright, now this turns into an algebra problem to get the x by itself. It's being divided by x. I don't want that, so I'm going to multiply by x. Anything I do to one side, I have to do to the other. Those x's cancel, so what do we have left? What does the equation look like? It's x times the cosine of a 32-degree angle is equal to 18. Remember, you really shouldn't memorize these steps. You should just have some fundamentals of algebra. So if I want to get the x by itself and it's being multiplied by the cosine of a 32-degree angle, I should divide by the cosine of a 32-degree angle, but anything I do on one side I have to do on the other. So those cancel and I end up with x is equal to 18 divided by the cosine of a 32-degree angle, and that is definitely that one right there. Okay, so take your time, fill out your equation, use your algebra, and you should be able to pick out which one is the right one. And I'll remind you, it does ask you to show your work. So if you just circle this one on the practice test, that is not enough to get you full credit for this assignment. Alright, number 13. I guess the thing that should stand out to us is this is a right triangle with a 45-degree angle. In fact, if it has one 45-degree angle, can you tell me what this one would also have to be? Well, if you did triangle sum theorem, you would find out that both of those are 45 degrees. And if both of those are the same angle, what do we know about these two legs right here? Well, then they're also congruent. So this one is also 3. In fact, if you totally forgot the shortcut, could you do Pythagorean theorem to solve for the hypotenuse? You sure could, but it's a lot faster to remember that in a 45, 45, 90, to figure out the length of any side, you just use the square root of 2. If you're getting longer, you multiply by the square root of 2, and if you're going from the hypotenuse to a shorter leg, you divide by square root 2. So can you see that we're going from the shorter leg to the longer hypotenuse? So all we have to do is multiply by root 2. So x would be what? 3 times root 2, which is 3 root 2. There would be the answer right there.
Alright, here's number 14. It says Julia is calculating the volume of this particular solid right here. Okay, and we have to figure out which one of these would give us the correct volume. So let's start where I think we should start, and that's by figuring out what solid this is. Now, hopefully we all see these triangles right here. And a lot of times when you see triangles, you might automatically start thinking about a pyramid. But is this a pyramid? Well, a pyramid comes to one point right at the top. So what if I thought this was a prism? Well, this is a prism. Okay, that there's only 2 polyhedra that we've studied in this unit. That's a 3-dimensional solid that's only made by segments. Can you see all the segments that are building this? So our prisms and our pyramids are these things that are made only out of segments. And we just figured out that this is not a pyramid, so the volume formula I should be using is what? To find the area of the base and then multiply by the height. Okay, so pretty much the most important thing that we have to do right now is figure out who is our base so that I can use the area formula, and that'll pretty much make it pretty easy to see which one I should pick. So a lot of times we look on the bottom for our base. So let's ask this question right here. Is this rectangle right here? Should I use it as the base? It's on the bottom. Well, hopefully in your geometry class you talked about how the base in a prism, there's 2 of them. In fact, they're exact copies of each other, and one is kind of raised right above the other one or right across from the other one. So I guess the question would be, is there an exact copy of this rectangle straight up above it? And can you see that this just turns into this one segment right here? So that actually could not be our base. Could this rectangle right here be the base? Could that be the base? Well, is there an exact matching face that's straight across from it? Actually, there's just this segment right here, so that can't be it either. And let's see, we even have this rectangle that's kind of slanted right here. Could that be my base? Is there an exact rectangle straight across from it? Nope, that's not either. So hopefully you're noticing, well, what about this triangle right here? Doesn't this triangle exactly match with this triangle right here? It does. These are the bases. This triangle here and this one that's straight across from it, those are the bases. So what if I were finding the area of those bases? Well, it is a triangle, so the area for a triangle is what? Base times height divided by 2. And in this case, that would be what? 9 times my height, 12, all divided by 2. Okay, so I've got the area of my base. That's done. What I need to do now is find out my height. Well, you might look at this and say, well, obviously the 12 is the height. Okay, and that is how tall the thing is, but here's where it gets a little confusing. That's not really the height for a prism. The height for a prism is how far apart the two matching bases are. In other words, how far apart are these two triangles? And can everyone see that that would make 11 the height of this prism, even though it's not like pointing straight up? All right, so we would take all this and multiply it by 11. Okay, so this would be how you would work out the volume. You change that to volume because we've added on the 11. So volume would equal 9 times 12 divided by 2, the area of the base, times the height. That's the volume. And which one matches with that? Can you see it would be letter choice B is the one that matches with that? Okay, so you'll have a problem similar to this on the test where you don't actually have to work out the volume, but they'll give you some sort of solid. It might be a cylinder or a cone or a pyramid, or it might be another prism, and you have to figure out basically what problem you would do, and you don't even have to do the problem. Number 15 gives us this dad mug. I guess Father's Day is coming up. Gives us this dad mug and asks us to figure out the approximate volume of liquid that the mug can hold. And there's kind of our key word. It is a picture of a mug and it's talking about liquid, but really this question is about what we studied this unit, volume. Okay, so job number 1 is to figure out which solid that we studied. Is this a prism, a cylinder, a pyramid, a cone, or a sphere? And hopefully we can all see that it is definitely a cylinder. So we'd look at our formula sheet on the test and pull out our volume formula for a cylinder, which is, you find the area of the base, which is a circle, and that area formula is pi r squared, and then we would simply multiply that by the height of the cylinder. So if I rewrite this formula, pi times the radius squared times the height, and just leave some gaps for the numbers I have to fill in. Let's see, how about what goes here? The radius. Well, the radius is the distance from the center of the circle over to the edge of the circle. And here's the little problem. Did they give, is 6 inches the radius? No, 6 inches is actually the diameter. So what would the radius be? Well, it's going to be half as much. That would come out to be 3 inches. So my radius is that 3 right there? It is 3. Okay, then the height of my cylinder is really the distance between my two matching circles, and it is the full 6. So we get 6 right there. And at this point, I've got my radius and my height filled in. I just need to do the math. Don't forget that PEMDAS tells you to work out the square first before you multiply. Okay, so that means that volume is equal to, we'll just leave the pi there for later. 3 squared is 9, and 9 times, and then we're going to multiply by 6. So 9 times 6 times pi, that's all going to come out to be 54 pi. And at this point, it's just going to be a problem for your calculator. They did ask for the approximate amount of volume, so we're going to type out 54 times pi on our calculator, and it should have said this, but it doesn't. We're going to round off to the 10th. So this one comes out to be 169.64, blah, blah, blah. But we're going to round off at the 6. So really all I have to look at is the 4. And what would the 4 do to my 6? Leave it or move it up? The answer is it would leave it. So we get 169.6. And our units were inches. And this is volume, so I'll say inches cubed. Okay? And just have to watch out for those diameters. It's easy to change a diameter into a radius or vice versa depending on when you need that.
Alright, number 16. Russell goes to the store and there's two ways he can buy his ice cream that cost the same, and he wants to get the most ice cream for his money. So one way to do this is he could spend his money and buy these two drumsticks. You'd get a certain amount of ice cream. Or he could just buy this tub of ice cream right here, and what he needs to do is figure out which one's going to give him more ice cream, and since they cost the same, he'll buy that one. So first of all, they want us to find the volume of option 1. Well, these are definitely cones. So what's the volume formula for a cone? It's pi times the radius squared times the height divided by 3. But what do you notice? How many cones are here? 2. So we're basically going to take this and multiply by 2, and that will give us the total amount of ice cream by buying 2. So let's see. Volume equals pi times my radius squared times my height all over 3, but we're going to multiply it all by 2. So let's fill in some numbers. Now be careful. The 4 centimeters is the radius? No, it's the diameter. So what would the radius be? It would only be 2. So I'm going to fill that in for my radius. How about the height of both of these cones? It's 12. I don't know why I put that right there. That looks like I'm squaring. I should be multiplying by 2. That looks better. Okay, so I am going to cancel my 12 with my 3 first. That would go how many times? 4 times. And 2 squared is 4. And 4 times 4 is 16 times pi times 2. So 16 pi times 2 gives me a total volume of 32 pi, and they are centimeters cubed. So there's the volume of the two cones put together. Alright, my next job is to figure out what it would be for this one. And what shape is this one? Can you see that it's a cylinder? So the volume formula for a cylinder is what? Pi times my radius squared times height. There's only one, so that's what it is. So this is going to be what? Pi times my radius squared times my height. Once again, be careful. They're not giving us the radius. What are they giving us? The diameter. So what would the radius be this time? It's going to be 2. So I'm going to fill in a 2 here, and my height, of course, is 8. So 2 squared is what? 4, and 4 times 8 times pi gives me 32 pi. So the volume for the cylinder of ice cream is 32 pi centimeters cubed. And now it says which option will give him the largest volume of ice cream, and what should we notice? They give him the same amount of ice cream. Now this might not necessarily happen on the test. If one gave him more, you would say which one gave him more, but in this case they are the same. So in a way, does it really matter which kind he buys? It really doesn't, as in terms of how much ice cream he will get. Alright, Bob is remodeling, number 17. Bob's remodeling his bathroom. He's going to put tiles on a shower wall, and it's 12 feet high by 8 feet wide. And the tiles come in sheets, so there's all these little tiles on one sheet, okay? And the sheet is how big? 1 foot by 1 foot. Okay, so Bob uses sheets of tiles to cover the shower wall. How many sheets will Bob use? Well, one sheet is 1 square foot. 1 foot squared. Okay, so we need to figure out how many square feet he has to cover. If he has 20 square feet, well then he needs 20 of these sheets. So how are we going to find the area of his shower wall? If it's 12 by 8, well that's a rectangle. So we're just going to do length times width, and 12 times 8 comes out to be 96 feet squared. So if each sheet is 1 square foot, and we have 96 square feet to cover, how many sheets? We will need exactly 96 sheets. Okay? Alright, then B asks us how many actual individual little tiles will end up being applied to the shower wall. So what we need to know is, we got 96 sheets. How many tiles are on each sheet? So here's what we'll notice. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many down? 1, 2, 3, 4, 5, 6, 7, 8, 9. So if it's 9 by 9, how many total tiles are on one sheet? 9 times 9 comes out to be 81. So if there's 96 sheets and each sheet has 81 tiles, can't we just do 96 times 81? And then will tell us how many of these little tiles we have. And you can grab your calculator and do 96 times 81, and it comes out to be 7,776 tiles. Okay? What if there was 49 tiles on each sheet? Well, then you would take the number of sheets and multiply by 49. So that's kind of how these problems work. Some of these numbers will change, but that's how you think through them. Number 18 tells us this quadrilateral is, what does this symbol mean? It's similar to this smaller quadrilateral. Okay? And then it asks us to find the perimeter of ABCD. So how would we find the perimeter of ABCD? Well, isn't the perimeter just adding up all four sides? So we're going to do 13 plus 6, that's 19, plus 8 more would be 17, and 10 more would be 27. It's 27 units to go all the way around the outside. The perimeter is 27 units. Okay, then they want the scale factor of quadrilateral ABCD to FGHJ. Okay, and what I basically need to notice is that I know just one side in this one, so which one would line up? Now you might think it's over here because those would be on the same side, but do you notice these two quadrilaterals are not facing the same way? In fact, this is like rotated 180 degrees, so who really lines up with FJ? Can you see that it would be AD? And they do want ABCD first, so that's the bigger one. So what would that be? 10 over 8. It's fine with me if you leave it 10 over 8, but if you want to reduce that, what number goes into both of these? 2. 2 goes into 10 5 times, and it goes into 8 4 times. So if you wanted to call it 5 to 4, that is the reduced version of that scale factor. Okay? So do make sure you match up corresponding sides. If you don't match up corresponding sides, it does not give you the correct scale factor. Okay, finally they want us to figure out the perimeter length of the smaller one. Okay? Now we only have one side, so we can't really add it all up. So what we're going to do is make a blank proportion. The scale factor, 5 to 4, goes here. And then we're going to put a ratio of perimeters right here. So should I put the 27 with the 5, the bigger number, or the 4? Well, can you see that 27 goes with the bigger one, so it should go up here on top. I'm looking for the perimeter of the smaller one, so I'm going to call it X. One quick question, should I square or cube anything? Well, we are working with perimeter, so do you square or cube? No. So our proportion is ready and we can just work it out. So 5 times x is 5x equals 4 times 27. Let's type that in on our calculator. 4 times 27 comes out to be 108. We'll divide both sides by 5 and what we get will be our answer. So 108 divided by 5 on our calculator comes out to be 21.6 units. And it did come out to be less than this one. Should it? Should it be less? Yes. And that's kind of a good way for you to make sure your answer is reasonable. So if it's a smaller shape, it should have a smaller perimeter, and our perimeter worked out to be smaller. Number 19 says Jazzy is going to paint the wall with the window, and you will need to pay attention. We've got two walls up here, but the person in your problem will not be painting both of them. Pay attention. This time it says she's painting the wall with the window, so that is this wall over here. She's not painting this wall or the ceiling or the floor, just this wall. Okay, there was a little error on this. It says 15 by 8, but the wall is really what? 16 by 8. So let's cross out that 15 and change it to 16. Sorry about that typo. It also says the window is 5 by 6 feet, but can you see it's 4 by 6 feet? So let's cross out that 5 and go 4. Okay, and obviously, when she paints the wall, would she need to paint the window? Of course not. You wouldn't want to paint the window. So the first thing they want to do is figure out how much of the wall there is that we have to paint. So can you see we need to calculate the area of the whole thing, but then subtract away the area of the window? So let's do the area of the whole wall. It is a rectangle, so that's going to be length times width. In this case, it's going to be what? 16 by 8. So 16 times 8. I'm going to tag that in on my calculator. 16 times 8 comes out to be 128 feet squared. Okay, except part of it's a window. So the next thing I'm going to do is figure out the area of the window, also a rectangle. And the rectangle is what? The window is 4 by 6. 4 by 6 comes out to be 24 feet squared. So how much is actually needs to be painted? Well, I'm going to take that whole wall and subtract away the window, and what I'd be left with is just the part of the wall that needs to be painted. That's 104 feet squared. Okay, so that's the answer to part A. Part B says she's going to buy cans of paint, and she doesn't want to buy too much. Each can contains enough paint to cover 50 square feet. Okay, so how many cans does she need to buy to cover 104? Well, would 2 cans do it? Well, can you see 2 cans would only get us 100 feet squared, and we have just a little bit more that we would have to cover. So she actually needs how many? 3 cans. Okay, having too much is fine. Not having enough to cover, you can't have that. So you have to, if it goes past, you have to round up to the next whole can. Alright, last problem on the test. Jack's Sporting Goods has a container that holds 3 tennis balls, each with a radius of 2 centimeters. The container is shown below. Its height is 17 centimeters. The first thing they want us to do is find the volume of the container. So, what shape is the container? If you ignore the balls, the container is very much a cylinder. And the volume formula for a cylinder is pi times the radius squared times the height. So, let's plug in the numbers we need to plug in and see how much volume we would get just for the cylinder. So the radius of the cylinder is the same as the radius for our balls, which would be 2 centimeters, and the height is 17. So 2 squared, 2 times 2 would be 4. 4 times 17 comes out to be 68 times pi. We get 68 pi centimeters cubed of volume. Okay. Now they want to know the volume of all 3 balls put together. Okay, so they are obviously spheres, so we're going to use what? 4 pi r cubed all over 3. But because there's 3 balls, we're going to take the volume of one of them and multiply by 3. And does everyone notice what's going to basically happen here? Does it really make sense to divide by 3 and then multiply by 3? Won't those 3's cancel? So really, for the 3 balls, not for one, but for all 3, it's just 4 times pi times the radius cubed. So let's see what we get. What is the radius? Well, there it is right there. It's 2. And 2 to the 3rd power is what? 2 times 2 times 2. That's what? 4 times 2, or 8. And 8 times 4 pi all comes out to be 32 pi for all 3 balls at the same time. Okay, so now here's the last question. The last question says, what is the volume of airspace in the container? So obviously, you got the whole cylinder. The balls are taking up part of the volume, but what the volume they don't take up is with air. And so what would we do to get the amount of volume of air? Well, can't we just subtract away the balls, and whatever's left is the volume that's left for the air? So what would that look like? We are going to do what? 68 pi minus 32 pi, and because they're both pi's, they're like terms, and we can subtract them. So 8 minus 2 is 6, and 6 minus 3 is 3, so we would get 36 pi. The volume of airspace would be 36 pi centimeters cubed, and that would be the answer for part C. Alright, remember you can watch this video as many times as you need. You might want to focus in on the ones that you have particular trouble with, and watch those maybe more than once. On tough problems, maybe change the problem and see if you can work it out with different numbers. After all, the problems on the tests will have different numbers and might ask you different questions. So the time you put into preparing pays off when you get a good grade. So good luck with your preparation.